Morty, we've got to turn the project in early.
Hey everybody, oh my gosh, the video is fuzzy. I did some changes yesterday. We got to make some quick changes right here. Can you hear the music? Is the music playing through? The music's playing. We got to fix a little bit of video here and then we're going to get started. Sorry, the video is a tiny bit fuzzy right there. Never make changes. That's the theme right there. There we go. I thought I reset the computer. I thought I wouldn't keep the changes. And we're going to fix this. Autofocus. Look at that. Turn on autofocus. There we go right there. And is the autofocus good or not? In and out of focus. There. Oh. So hard to get it perfect. Oh, there we go. There we go. Hello, Caroline. Good to see you here. Hello, Hayden. We're going to get started on the project here in a second. And I think, is everything good here? Good. I think we're good. Everything's good enough for work right now to get started. Try to get the autofocus. I don't understand. I wish it would focus a little bit better. We're going to get started on the project. Are people ready to work on the project? Hayden and Caroline right there. Project time. Had some meetings this morning. It has been a crazy week. My car's wife is in the shop, and so I've been driving her to and from work. So we've got that. So we're down a car, but I get to hang out with my wife, which I like. And so it's just been really, really busy. Really, really busy. What is that? What am I gonna? Oh my gosh, it's a piece of dust. I'm ready, says Caroline right there. We're gonna get the project up and going right here. We're gonna throw out some points from Mubot. Mubot's got some points. We got the camera fixed. All this stuff going. Let's get the chat over here. I ran back over here. I was in a fun meeting. I was in a meeting about technology for students. So it's a new device that allows people to share and basically broadcast stuff. So it was really good meeting. Got to see some new technology, and the guy got here I think at 9:30, so I had to run over there, went through that, and got to see some cool stuff. Good morning, Kyle. We're starting up the project. Have your project open. Good morning, Catherine right there. Mubot, is Mubot not awake? Mubot, you not throwing out points? I thought I clicked points. Gives out some points, Mubot. How different is the in-person project meeting compared to the online? Basically sort of the same. We'll go through. We're gonna start here from the beginning. This is recorded, and I'd say it's pretty similar. Here we go with the Stats 1 project. And the project right here. Let's us start talking project talk. Okay, the Stats 1 project. Let's mark this in the notes. I need to go through and remark yesterday's class. Here we go. The start of the project. We'll be back at 1. Awesome. This will stay up on the channel, J-Boss. Good to see you here. This will be recorded and time-stamped later. The 453 advice for project. We're starting off with some advice for the project. How will you be graded on this project? How are you graded on this project? By the what? How are you graded? We used to not have these. How are you graded on the project? Like, know this first off. How are you graded on the project? How are you graded? The rubric. I can't state this enough. People say to me, well, what do I need to write? Well, just look at the first thing on the rubric right here. It says first thing is, did you submit early? Well, that's not writing something. It's just, did you get it in before the 30th? There you go. First thing is an executive summary like you did with the last data analytics. And it says right here, if you get the full points, it's clear from the start who the project is for and what's being analyzed. Now, you won't write the executive summary to start because you haven't written your report. So when doing the project, the executive summary will be written when, which is 15 points right here. 15 points will be done when. So when do you write your executive summary of a report? The thing. When do you write the executive summary? You write it last. Now, it goes first on the report. It's the very first page of a report is the executive summary, but you do it after writing your report because you have to know who's the report for, what did we do, what are our key findings with numeric backing. So make sure must use numeric backing right there. And then last, the action item. The grade should be similar to what you got on Data Analytics 5 for this portion, as in if you did well on Data Analytics 5, you should do well here. Then you get into the one sample Z test. Next, you have the one sample t-test. Then you have another quantitative variable of interest right there, regression output, the slope interpretation, the intercept interpretation, and the R-squared statistical significance. Literally right here, determine whether or not the regression is statistically significant and include the p-value. If you're wondering how you'll be graded and what you need to say, when you're doing statistical significance, you need to determine if it is statistically significant. So I'm not telling you what to write here, but it'd be something like, this regression is statistically significant because the p-value of this is below 0.05. And that would pretty much answer the question. When should the last data analytics be graded? They have 1 week to grade assignments. I kind of get on their case if they're not grading them within 1 week, but they have 1 week to grade the assignments. So whenever you're doing your report, make sure to look through each of the things on the rubric and analyze what it has and answer the questions. So I've been using a data set all semester. Let's start with the project right here. We're going to start with the project and talk about taking a random sample, which do we not require? We might not require you to do. Do we require the random sample? I don't think we do. Let me go look. Under the instructions, we put it here in case we need to make changes. There it is. Here's the instructions. There it is. A random sample is being taken. We've not required it at all times, but this time it is a random sample. So the first thing we're going to do right here is take a what. So what is our first step in doing the project? There might be. They send out reminders and check out their group me's. Promote that right there. Check out their group me's. What is the first thing we'll be doing in our project? So take the notes right here. What is the first thing we'll be doing? We're kind of doing it in order right here. The first thing we're doing is taking a random sample. So I have my jump data set. What you want to do is you want to get a jump data set open and have it like this. You will go and you will use one of the following data sets over here. To make sure you're not working with somebody, remember these all these ideas are your own. Don't look at someone's screen. Don't have someone send you their work. Whatever you do, do your own work. And then you could ask somebody, what do you think of what I've wrote? Now, if they open up their computer or start writing things and using what you've written, that's them copying you. But you are allowed to say to somebody, do you think this sentence sounds good? The best thing to do probably is to give someone parts to be like, I think I wrote this sentence weird. And then to be like, yeah, you could maybe write it this way. Now, if they start writing what you wrote, they shouldn't be doing that. They should have their own original ideas and be doing their data set and not saying, well, you wrote it this way, I'm going to write it this way. There's not one right answer in statistics. There's just different ways to talk about things, and we all write things our own way. So once again, don't work with somebody. You can help somebody as in, you know, like SI helps or like I help. I don't tell you what to write. I give you ideas on what to write. So let's go right here and take the random sample. And we will take a random sample of 300 plus our last two of our UTID. Your data sets have the jump data set here, and you should probably look at the what. I can't state this enough because I think so few people do it. You should look at the what for the data set. What should you look at for the data set for some points? We got to throw out more points. So download your data set and also look at the what for your data set. The what over here. Each data set has with it its own what. There. You got to get the points with this. You have to say the answer. Every data set has its what with it. It's documentation, which tells you what the data set's about. So look at the documentation to learn what the data set's on, and then ask questions if you don't know what it is. I know about Pokemon, so I'm doing Pokemon. Thank you everyone right there with all those answers. I need to go from top chat to live chat. So I'm going to go right here, and this is how to take the random sample. To take the random sample, go right here and go to Tables, Subset. Table, Subset. With Table, Subset, we are now going to enter in 300 plus the last two of our UTID. My last two will be 12. So you'll enter in 300 plus the last two of your UTID, bring the window back. And with 300 plus the last two of your UTID, you'll click OK. Now you will not take pictures of this. Just make sure you have 300 in what the last two of your UTID is right here, and then go to File, Save As, and save it as your random sample. How's everyone doing right now? Does everyone have their random sample, which is very important to do your own work and get your own results? How are people doing? So you should have clicked on one of the data sets. So go back to the instructions right here. Click on one of these data sets that interests you, and then go to, I'll show the process again, go to Tables, Subset, and under Table Subset, type in under random sample size 300 plus the last two of your UTID, not this number I'm typing now, and then click OK. Each random sample is different. It doesn't work. What does it say when you download it? That's why if you're here right now, what does it say when you download it right there? What is it saying when you download it right there? 300, because this is very important. It is squares and random letters. Inside of Jump, make sure to go to File, Open, and make sure you're downloading the Jump file. So make sure you're inside of Jump right here and go to File, Open. So have Jump open and then File open. It might have tried to open it in a notepad or something else, and it might not be recognizing the Jump format, making it look like random characters and just a bunch of nonsense. So make sure Jump is open and then File open. Justin, good to see you there. And did that work right there, Elizabeth? Make sure in Jump to be inside of Jump and then go to File Open. And with File Open, you should be able to open the file inside of Jump. Make sure any file you're trying to open inside of Jump is a .jmp file and Jump is installed on your computer. What do we hit to put in the random sample number again? We'll do that again right here. Once you have the file downloaded, with the file downloaded, go to Tables, Subset. Tables, Subset. Garrett, good to see you here. Table, Subset, and then random sample size, and then 300 plus the last two of your UTID. Did that help out, Space Cat, right there? So now we click OK, and we have our random sample right here, and we go to File, Save As, and save your random sample as my random sample. How's everyone doing on taking the random sample? Which is a very important step to make sure you're doing your own work. Everyone good on that? You're welcome, Elizabeth. Good work right there. And just if something doesn't work, let me know. Catherine's good. We got our random samples. Well, we're one step done with the assignment right here. I think we've got it open on another tab right here. Go over, where's those instructions at? Here we are with the Stat 1 instructions. So here's the prompt. You don't have to say exactly this. Some students are like, I have been working for this company for 3 years. The reason we have this right here is to give you the background on what you're doing. You're not new to this company. You're a decision maker in this company. You've been working for them for 3 years. You're analyzing a data set of your choosing, and you'll be using your imagination and new ideas to create research revolving around an idea. So I am part of the Pokemon League. I have been in the Pokemon League for 3 years. I am going to be analyzing the most powerful and strongest Pokemon that exists. Does that make sense? That is like the opening to my executive summary right now. I, Brian Stevens, am a trainer in Pokemon. I've been a part of Pokemon League for 3 years. We are trying to figure out the most powerful and strongest Pokemon to help trainers with their quest to be the best. Does that make sense? Like that's kind of we haven't written the executive summary yet, but we're getting an idea of who we are and what we're doing. You will be your own person within your own company and deciding what you are researching. You won't be researching Pokemon like me, hence why I can kind of give more sentences on who I am and what I'm doing, because it won't relate to what you're doing and you'll have your own unique report. What you choose to do will be based on the decisions you make down here. So you might not know the executive summary yet. So are we writing the executive summary right now? Are we writing the executive summary right now? Yes or no? Are we writing this? We're about to do the next thing, which it says executive summary right here. No, but in the report, the executive summary would be first. So we would go back and write the executive summary after we do the report and put it first. Blakely's got it right there last. Great work. So we're actually going to start right here with the one sample z-test. So let's start up the next section. If you're following along, we're going to mark this in the video, Stat 1 project, and the one sample z-test. So a one sample z-test, so do you write the prompt? You don't write exactly the prompt. Really quickly on that, Space Cat, good question. I wouldn't include the prompt as per the prompt. The executive summary is what's graded. The prompt is to prompt you on what to write, but the executive summary is what we grade. You are not graded on writing the prompt out. You are graded on do you answer the executive summary. So the prompt, if you notice right here, doesn't have any points associated with it. It's a prompt informing you of who you are and what you're doing. And then you'll use or kind of say like, I am Brian Stevens, a trainer in the Pokemon League. Don't write I am someone. You don't have to write exactly what I write. So executive summaries will be different. But I would say something like, I'm Brian Stevens, a trainer in the Pokemon League. We are trying to research which Pokemon are the best Pokemon for attack and something else. We've analyzed these variables, and when I get to my executive summary, that's what I write. It would be based on the idea of the prompts, like I've been with this group for 3 years, but this information right here is not going to be copy pasted, entered into. And the executive summary will be the very first thing in the report, but you write it last because it's basically an executive summary of the report. Space Cat, great questions and answers right there. That's the clarification I want to give, because it's like, wait, why am I writing this last? Well, we have to write the report and then summarize the report. We're going to change the timestamp here just really briefly. Please keep those answers coming, or questions coming, because if you're here, I want to answer all the questions. So what is a 1 proportion Z? A 1 proportion Z, actually, it's so funny I have it on the screen, is this. This is the 1 proportion Z test. So this is a 1 proportion Z test, and this is a 1 proportion Z interval. The 1 proportion Z is used for what? Quantitative or categorical data. These are notes, take them down, practice for the test. That's the 1 proportion Z interval, and the 1 proportion Z test is P hat minus P naught over P naught Q naught. Is this used for quantitative or categorical data? Is this used for quantitative or categorical data? Quant or cat, what do you think? This is the interval. This is the test. Is this used for quantitative or categorical data? The 1 proportion Z interval up top and the 1 proportion Z test down below. It's used for categorical data. Great job, Caroline, right there. We got cats in the chat. It's because the interval estimates the true proportion, and then the test tests a hypothesized true proportion. So this is for categorical data because proportions are categorical, like P hat and P naught, those things right there. Check out the videos where we go over these equations more in depth. So when we're doing in jump right here, we need to first pick a 2-level categorical variable. A 2-level variable is something that has 2 answers to it. It's something like, would you like chicken or steak? Would you want to buy a cat or a dog? Do you like to drive fast or slow? Do you prefer the mountains or the beach? Things like this are 2 levels. So the levels of a categorical variable is how many answers there are to the question. Yep, we'll be helping in person, Catalina, you bet. So when you look for a 2-level categorical variable in your data set, the best way to look for a 2-level categorical variable is to go over here and click the following button. Do you see there's only one 2-level categorical variable in my data set? What is it? So look at the top of the screen and tell me the only 2-level categorical variable. Now, if you're looking for categorical variables, you also have to see if it's red. Red means categorical. So those are the only ones that could qualify. All the other ones are quantitative, or identifiers posing as quantitatives, which the number of a Pokemon is the identifier. Actually, it might be the name too, because they repeat. We click right here, this button right there. This button right there can let you view a short summary of the data in graphical format. So which one of these is a 2-level categorical variable? Do you see it in my data set? I'm stuck with picking only one. You might have more than one pick, but I have to pick one. So identify the 2-level categorical variable. Levels just means how many options there are to a question. So there is a categorical variable, and red is categorical and jump, blue is quantitative. So what is my 2-level categorical variable? What is my 2-level categorical variable? Legendary, Caroline, you're right, with more points right there. Legendary is the only variable I can analyze for this. So I'm going to say, we are really interested in legendary Pokemon. So that's what I'm going to say right there. Once again, don't say exactly what I say. I am really interested in this. There's so many ways to say the variable we've chosen to analyze is this. We will be examining this variable. We are going to look into this variable. This variable is the variable we've chosen to analyze. There's so many ways to say it, so don't type exactly what I type. Be like, I like this variable. I'm going to look into it more. Make sure, okay, there we go. Identify which one you would consider a success and why your company is interested in this. Our company is super interested in the legendary Pokemon and to understand things about the legendary Pokemon and how they are different. Why did I choose legendary? Legendary are cool Pokemon. That's why I picked it. Like, man, when you say you have a legendary Pokemon, like, oh, dude, I got this legendary Pokemon card. People are like, what is it? You're like, oh, I got a regular Pokemon. Oh, who cares? People are highly interested in legendary Pokemon, and they oftentimes have stats that are different than other Pokemon. Like, they might have very high stats. So we are interested in the legendary Pokemon, and the level of interest is true. Does that make sense? I have now stated the success is being a legendary Pokemon. So it doesn't matter which categorical variable you choose, correct? It just needs to be a 2 level, and you need to identify that it's a 2 level by looking up here and seeing it has 2 levels, and then talking about the level you're interested in. Like I'm saying, we want to understand the legendary Pokemon, which would be true. We are marking that as a success. Does that make sense? The level true is a success. So you need to pick one of these levels, true or false for mine, and then say true is going to be a success because we are interested in the Pokemon being legendary. So now we've done those parts. Notice how we're doing each of these questions right here. Pick the variable. What is a success? Create a bar chart and a frequency table of the variable you choose. Make sure your bar chart's in horizontal layout and bars have values over them, each count or percent for each column. This frequency table should include the counts and proportions, and make sure dark mode is off. I have a video going over that. If you have dark mode on, you can't see the numbers, please let us know. I'll have to send that video, or I can find it here in one moment. Actually, let's find that really quickly now and put it as a link, because I'll have an easier time finding it than you will. And the dark mode video, search my channel for it. Dark mode. Here it is.
If you're having an issue with the
Here's the dark mode video on how to turn off dark mode. And so turn dark mode on max. I don't know why they haven't fixed this. I missed the beginning, but do we choose any jump file? You can choose anyone and take a random sample of 300 plus the last 2 of your UTID. Technically, we could, don't choose the Pokemon one, but if you're in my class, I wouldn't be opposed to you choosing any jump data file you want, but technically use the ones we've supplied. Don't use the Pokemon one, whatever you do. Don't use Pokemon because I'm doing that, and that could lead to a lot of overlap on what I do. So with this right here, make sure dark mode is off, and let's go create that bar chart. To create a bar chart, we're going to go here to Analyze, then Distribution. Analyze, Distribution. Once you click Analyze Distribution, double-click the variable you're interested in. So we're going to double-click the variable, legendary for me. Notice it appears right there, and then click OK. Once you've clicked OK, we're going to go right here and click the top red arrow and click Stack. Now, we're going to go right here to the second red arrow and click Histogram Options, and then Count Axis, then Histogram Options again, and then we're going to click Show Counts. You can also do other things if you want, like histogram options and histogram color, make it a nice light purple. It's all your choices right there, just depending on how you want to do it. So we now have, great job Blakely right there, we now have our bar chart right here with the data analytics on it. If you notice, we need to understand what all these numbers are. Let's start interpreting the numbers. So I'm going to call this creating the bar chart. I'm going to mark this in the video. So this is a bar chart right here because it's categorical data. I know it does say histogram, that bugs me a little bit, but this is a bar chart because you can make bar charts your favorite pies and pie charts your favorite bars. It's categorical data. Is a Pokemon legendary? Categorical. So what you notice here, 296 means 296 of my 312 Pokemon were not legendary. 16 means 16 of the Pokemon were legendary. The percent of Pokemon that were not legendary was 94.8. And the percent of Pokemon that were legendary was 5.13. So that's what those numbers mean. There are 312 total Pokemon, and there was no missing data. We don't need to comment on that. And there are 2 levels because there is either legendary, not legendary. Make sure this says 2 levels. That was part of it. Screenshot this and interpret the data, and I think you're good. So we should have the bar chart done right now. How are people doing? Have you created a bar chart? And you need to interpret your own bar chart with your own words. So if you notice right here, include a screenshot and visualization, provide a short descriptive write-up of the variable, making sure to cite the numbers in the graphic. And that's what you were hearing me do just a moment ago as I was talking through each of these numbers, with the counts of the observations for each of these and the percents right here. When taking your screenshots, make sure to take a good screenshot. There's a good screenshot right there. And if you get a little bit more of the screen, so let's say you make an error and you get a little bit more of the screen right here. You want to go right here and click on picture format and crop, and then crop the picture right here and click away. You can do extra things. It's not bad to do, like adding borders. Just make sure the border doesn't really detract from the image. Just depends. So just click something right there, add a border, depends what you want. Center the image, make it look nice. All these good things you can do with formatting to make your project look a little bit better. How are people doing? Do people have your bar chart created and then start interpreting it right now? Do people have the bar chart created and then you can interpret it? Know what the numbers mean. And also know that if we're talking successes, in notation, this would be X, and this would be N, and this would actually be N minus X. We don't usually say that, but that is the amount of failures. The sample size minus the successes would be the amount of failures. This is X over N equals P hat, because that's the sample proportion. And then this would be technically N minus X over X, which is equal to Q hat. So we don't usually solve those out like this, but P hat and Q hat are complements. They add up to 1 right there. You can see the P hat Q hat relationship, and X is the number of successes. Notation is very important for the test, and jump is just showing you a summary of the data. Do people have a bar chart? I'm waiting to go on right here. I just want to make sure people have a bar chart. You've got it created, it's visualized, you can see your bar chart, and you know what to analyze with it. How are people doing? So give me your thoughts or ideas or concerns, because we're already a few points in. Good, nice job, Caroline. So now we need to make, good. Do you include the notation? No, don't include the notation. That's why I erased it right here. It doesn't ask for notation. Include an interpretation that gives numeric backing. So as you're working on the project, also make sure to read things right here where it says like, include a screenshot of the visualization, provide a short descriptive write-up that includes the numbers from the graph. So that's what you need to do right there. Make sure to do that. I might do a little extra because I'm trying to connect the ideas between what we do. And so make sure to do that. Create a confidence interval, choose any % confidence other than these. So I want you to notice what I'm gonna do. So you have to be listening to the video here. So let's say the confidence interval, I'm gonna mark this in the video. That's one project. Confidence interval for proportions. So when you create the confidence interval right here, you cannot use what percentages. When you create the confidence interval, you cannot use 90, 95, 99. So with this right here where you see confidence interval, you cannot use these. Don't click these. I'm going to make it a little bit bigger on the screen so you can see better. So we'll bring the Word document in the background. Oh, now it's doubled up. Here we go. New Word document. Blank background. Jump output. Here it is. So when you are doing this, do not click these. You will click Other right here to make your confidence interval. And then right here, you will enter in another number other than 90, 95, or 99. Don't enter that in. So I'm not entering in another number, but you know, don't pick something crazy. Don't pick anything below 80%. Don't pick exactly 80% either. I don't want to see everyone getting 80%. But you should have a unique number to you entered in, kind of, sort of, and that is how confident you are. Don't pick 90. I want to see someone in the chat for 1,000 points say, don't pick 90. Because someone's going to pick it, and then they're going to lose points and say, well, Brian did it. I'm like, no, I'm doing it because you can't do it. That's why I'm doing it. So that way people don't have 90. Don't pick 90. Emma, thank you so much. Catherine, thank you so much. And Caroline right there. Don't pick 90. Don't do it. Don't do it. You'll lose points. Pick another number. Don't pick 90. Thank you, everyone right there. Tristan, good work. So here we are with the interval. Let's look at the interval. And you know what? We can screenshot this, but here is our confidence interval right there. Don't pick 90, and good to see you there. Don't pick 90. Everyone knows now. We're going to screenshot this once again. We've made our confidence interval. Nice, clean screenshot. Remember, you can edit them if you get too much. So we're going to go back here to our document and insert the screenshot of the confidence interval. We're going to make it probably appropriate-ish size. Oh, look, I got part of the screen. So, crop picture, bring down, and that part's been removed, and we're good to go. How'd you get to confident? To get to confident, go right here and go to the red arrow. On the red arrow, thank you, Justin, right there. Select confidence interval and then other. Select confidence interval and then other. So the red arrow, the second one, red arrows are where the options are at. Confidence interval, other. Confidence interval, other. And then enter a value other than 90, 95, or 99. Good questions, Elizabeth. 500 points. Thank you for asking. And so now we have our confidence interval right here. We're once again going to give it a nice little background to make it look a little pretty right there. A little bit better. And with this, what does this all mean? Once again, don't write down the notation, but know it. This is X. This is N minus X because it's the amount of failures. This is sample size. This is P hat. Nope, that's Q hat. It's not a big deal.
It doesn't matter.
Yes, it matters a little bit. That's Q hat. That's P hat. And this is the lower, and this is the upper, and this is the confidence level. So when you interpret an interval, and these are things that we don't usually look at for plagiarism because we have a standard format. So if these parts highlight on a report, we don't talk about plagiarism here because we know a lot of people are going to say, I am blank % confident that the true blank is contained in the interval blank to blank. Now, 1,000 points if anyone can tell me how to interpret my interval, and you have to remember what I'm trying to analyze. So what am I trying to analyze? What is the context? And did you say put X as P hat? Oh no, you don't mark the notation. I'm just marking that there for understanding purposes. P hat is 5.128%, and Blakely's on the right track. So those are just interpretation things to understand. The interpretation of the interval is the I am this. So give it a shot right here. Try to interpret the interval, and we need the context. The context will go in here. Why would true be the one that you would take the lower and the upper from? Because that was the one I was interested in. That's what we labeled a success. So remember earlier we said that true is a success. So that's going to be the interval that I'm going to interpret, because since true was my success earlier, and good question right there. True is the success. Thank you, Caroline, right there. I need the full, pretend this is a test, Blakely. You got it. And here's the thing. This is where people get confused. We'll either say proportion, don't say all of these, mean, or difference in means. You don't pick all of these. So how is this interpreted now? So you have the context up here. The context will go right here. And then depending on what we're doing, if it's proportions, means, or difference in means, we will interpret those. So what will this be? I am 90% confident that the true proportion. Close, Fritz. I'll throw you 1,000 points for that. Fritz, you're just missing a tiny bit of context. And then you also moved the decimals a little bit, but Fritz, you're on the right track. Good answers, Fritz. Let's throw 5,000 points. Why not? A little more correction. Savannah, good to see you there. We're about to start the next section after this, so we'll be doing some t-test after this, I believe. So you're really close. Let me highlight what we need. So the context is up above. We are currently doing proportions, the categorical data, and then we'll be doing some new stuff here in a second. New section. So I've got it highlighted. Give it another shot. This is a test question. So what would it be? I am. Fritz was really close. Pretend this is a test question. You were missing the context there. I am 90% confident that the true what? And you were right, it's proportion. But in a moment, and the reason I pause on these are test questions. You need to be able to write this out. In my class, a lot of times we're just practicing, writing it out. So try writing it out, but not of the variation. So I am 90% confident The what? So what is the context of this? I'm trying to understand what. What variable am I analyzing? What variable am I analyzing? True proportion, correct, of what? I am. So write the full thing though, because on the test you have to write the full sentence. It's worth 8 points. So I need the full sentence for practice right here. I know I pause on these things a while, but then people get to the test and they say, I don't know what to write. And I'm like, no, write it out. I am 90% confident the true proportion of legendary Pokemon is Justin, 5,000 points. Yes, yes, yes. I am 90% confident the true proportion of legendary Pokemon is contained in the interval. Boom, said it perfectly right there. Exactly, Justin. Pinned answer in the chat. Great work. You got it. That's what the test is going to require. It won't always be proportion. It won't always be mean. It won't always be difference in means. These are 3 different chapters. Don't write all of them down. Make sure to pick the proper one and then interpret it based on that. And the context is what Justin put down there. Check out the color coding. Look at yours and see what applies. The yellow is the context. The green is the confidence level, which you times by 100%. And then the interval is the lower to the upper of the level you're interested in. So really great work right there. And I think that wraps up the first section right here. Well, no, a little bit more. Interpret to the reader the confidence interval right here. Oh, now we got to do a test. So now we're doing a test where we're using 0.33 as a hypothesized value. It won't matter, Caroline. Good question right there. You can pick whatever level you want to be a success. So now we are doing a proportion test. One proportion test. So to do the one proportion test, remember we gave the notation earlier? We are coming up with P naught. P naught is equal to 0.33, and we've just told you that. But here's the thing. Do you think 1/3 of Pokemon are legendary? Does anyone know Pokemon here? Like Articuno, Zapdos. I don't know the song well enough. Do you think 1/3 of Pokemon are legendary? The null hypothesis would be, which it might ask you to write out here in a moment. The null hypothesis would be the true proportion of legendary Pokemon is equal to the hypothesized. The hypothesized is this. The alternative, we'll look at what they want, is going to be the true proportion of legendary Pokemon. Which side are we going? But do people think the null is true, that 1/3 of Pokemon are legendary? So here we are, believes to be the true proportion. You consider it a success. Clearly explain to the reader the point of the test you're performing and why it's important to the company. Use statistical notation, explain the null and alternative. Is this as in the department as the... Yep, this is what we'll be doing in the department. We'll be doing this in person and I can meet with you and go over it. So Milton area from 1 to 3. So this is the null and the alternative. My company wants to know if legendary Pokemon are out of control. We have to make sure that there's not too many legendary Pokemon in the ecosystem. The conditions, did it say conditions? Space Cat? I missed the conditions part. Thank you so much. For the reader. Oh, down to the conditions. Oh, no. Okay, we got to go back. Okay. Just right here. Only mark this as conditions. Thank you. Batone projects. Conditions for interval. Sorry, missed that right there. 1,000 points. So right here, name and identify the 3 conditions. Every time in our class we talk about the conditions, we always say condition 1. Condition 1 is randomness. How do we know this is a random sample? How do we know? Blakely knows right there. How do we know it's a random sample? How do we know it's a random sample? Now we'll go late today because I did start a little bit late, so we will make sure we put the full project here. How do we know it's a random sample? How do we know that? Condition 1 is randomness. How do we know this? Because we took a random sample. Go write a full sentence on it. Write a sentence and a half on it, and write a full sentence. We did it. Like, don't say just we did it. You know, make it clear. I don't want to tell you what to write right here, but you can explain why we took a random sample. Condition 2, 10%. Now this is where it gets iffy for mine. I'm gonna say, we know, because you know, they're always finding new Pokemon. Our company estimates that there are actually around 5,000 Pokemon. Don't use my numbers. Don't say we think there's 5,000 this. Don't say our company estimates this. Because here's the thing. If we do University of Tennessee students, how many UT students are there? If we do UT students, there are like 35,000 UT students. So if you have a sample size of 35,000 and you take a sample of 300, not capital, you take a sample of 312, that would be way less than 10%. So I'm coming up with a Pokemon number from my theoretical research to explain that my 312 Pokemon are less than 10% of the total Pokemon. Does that make sense? The 10% condition, and Blakely, good work right there, is that we sampled less than 10% of the total population. How are people doing on the 10% condition? Do you understand that the 10% condition, you'd write this out as sentences like the condition of 10% is we need to take less than 10%, and good to see you there, Sandra TV. We need to take less than 10% of the total population. So make sure that's explained, and maybe you give estimates of the population size and talk about how your sample size of whatever is less than 10% of the total population. Success/failure condition says we need at least 10 successes, at least 10 failures. Well, in our data, how many successes? I mentioned this previously. In our data, we had how many successes and we had how many failures. So you can directly quote these numbers. In our data, and I got a little bit lucky, in our data, we had how many successes and how many failures. Do you see them? Successes is X, so I marked it earlier. How many successes are there in the data and how many failures are there in the data? How many successes and failures are there in my data? They're on the screen here somewhere. They're on the screen twice. Almost behind my head. 16 and 296, Tristan on fire right there. You're right. And so there are at least 10, and state that there's this many successes, there's this many failures. Use your own wording. You just got to tell someone the facts. There's a fact, they're greater than 10, you're good. So that's how it works. Does it make sense on the conditions right here of random, 10%, and success failure? Random being we took a random sample, 10% being our sample size of whatever sample size we took is less than 10% of the total population. Try to give some numbers to back it. And then also success failure being we've had at least 10 successes, at least 10 failures, and give the numeric backing to say we meet the conditions to properly make and interpret an interval. So we've got that good right there. Let's jump to the test. The one proportion z-test. So the one proportion z-test has us using the hypothesized value of 33%. In classical statistical notation, it'd be written out the following way, that the true proportion is equal to 33% and the true proportion is not equal to 33%. So what is this stating? It states that I believe the what of what is equal to 33%, which sounds crazy when you think about Pokemon. Remember, I'm analyzing legendary Pokemon. Brian currently believes that the what is equal to 33%. Just try to understand what we're saying right here. Like, I think at this moment that what? Justin gave the context earlier. So you remember the context of what P is? It's what? Brian believes what? And remember we said this earlier? Said the full thing right there. So what does this read? I currently believe my null hypothesis is that the what? I don't think it says write the notation, but I'd probably write the interpretation right here that I'm saying. I believe that the proportion, the true proportion of legendary Pokemon is 33%. Like 1 in 3 Pokemon are legendary. So a really simple way to state this is, I believe 1 in 3 Pokemon are legendary. The alternative is it's not the case that 1 in 3 Pokemon are legendary. So we're looking for evidence of that. And to do this, we'll run the test in Jump, and we'll double check the rubric to make sure we have everything done in a moment here to make sure we got all the points. So now we go here in Jump. In Jump, click the following button. You want to go here to the second red arrow and go to Test Probabilities. The second red arrow and go to Test Probabilities. With the test probabilities, you'll see a screen appear over here, all the way on the far side of the screen, and then you will enter in the following. Under the level of interest, the one you called a success, you'll enter in 33%. You'll then enter in Q0. So this is technically Q0, because if this is P0, the hypothesized proportion, this is Q0. the complement of the hypothesized proportion, and then you will run the test with those hypothesized values and click done. And think, like we said, 33% is a really absurd value. It's so absurd that the p-value is basically 0. We're going to use the Pearson p-value right here, and notice the p-value is, for the exact summary, do we have to write the paragraph? Nope, you don't have to do the exact same thing. We'll be doing that here a little bit later, so check out that section. Thank you, Savannah, good question. So right here is your p-value. Is this p-value statistically significant, yes or no? We should know that. Is that p-value statistically significant, yes or no? What do you think? Is that p-value, we have a saying in our class, when the p-value is low, reject the null. When the p-value is high, just let it fly. So is that p-value statistically significant, yes or no? What do you think? Definitely one of the choices. Don't worry, 1,000 points. The answer is yes. So 1,000 points right there. It's statistically significant because it's below 0.05, which is what we usually assume alpha to be. Statistical significance literally means, whenever we say statistical significance, is p-value below alpha. Alpha is when something is significant, usually 0.05. So alpha is the point at which we call things significant, and it's usually 0.05. So with this, that p-value of 0.0001 or less than that, it says in JUMP, is less than 0.05 and is thus statistically significant. Does that make sense? Good answers right there, good practice. A low p-value means unlikely by random chance, and this p-value is low, i.e. statistically significant. So that is very statistically significant. We're going to take a screenshot of this output and bring it over. Good answers, Caroline, good practice. Here we go, we grab the data and we bring it over to our assignment and we bring it in here. Whoops. Right here, drop it in. Make sure it looks nice, make sure it's sized up well. Give it a border if you want. There you go. We got it. Let's look at the questions that are asked for this and go ahead and start answering them. Finally, using your confidence interval information, make a decision about the null hypothesis and write the conclusion to the hypothesis test. Explain how the confidence interval assisted in the process of your decision about the null hypothesis. So this is how confidence intervals and tests connect. So I want you to notice this. The confidence interval goes from 0.034 to 0.076. Let's write those down. 0.034 to 0.076. Just like a Pearson question, what do you notice about the hypothesized value here? The hypothesized value there is where? Where is the hypothesized value? Where is the hypothesized value? Oh, because I want to see if there's too many legendary Pokemon in the world. Good question, Space Cat. So that'll be your context. We want to know because we think legendary Pokemon are getting out of control, and we want to see if there's reason to believe that there are 33% legendary Pokemon. So I'm examining the what did I say? The amount of legendary Pokemon that exists, or the proportion of legendary Pokemon that exist, because we think if there's 33%, that's too much. So we're wondering if it's 33% or not 33%. So we're going to see if it is 33%. I'm just repeating myself now. But does that make sense, Space Cat? It'll be on you to say, well, we think it's 33% legendary. And you might think too little, too much, or it depends on your context why you're examining 33%. Does that make sense, Space Cat? So I think 33% legendary Pokemon's too much. And you don't have to use those. Don't say, I think 33 is too much. You could say, 33% is very interesting to us because that's the point at which we make sales, or that was our goal for last year for the company, and we want to see if we have reason to believe the goal is true. 33% is something a boss wrote in an email, and we're double checking the boss. So whatever context you want to come up with, you see how I can come up with, watch this, 5 different contexts. 33% is too many legendary Pokemon. 33% was the number my boss gave in an email. 33% was our goal last year in the company. 33% is something, a rumor that has been spread about us online. 33% is last year's numbers, and we want to see if they changed from last year's numbers. Those were 5 different contexts, and I just came up with them like that. So we want you to come up with your own. Don't write exactly what I say. So, no, Space Cat, 5,000 points. Please asking. How do we explain the null and alternate hypothesis and the does not equals test without using statistical notation? So here is, let me go back to it. The statistical notation looks like as follows. And really great questions. A lot of people are probably watching this, and that's going to help them out. Remember how we wrote it out in statistical notation like this? So this is how it looks, but watch this. My null hypothesis is that the true proportion of legendary Pokemon is 33%. The alternative hypothesis that I'm examining is the true proportion of legendary Pokemon is not 33%. Does that make sense, Space Cat? I basically read it as a sentence. I'll underline it as I read it. My null hypothesis is that the true proportion of legendary Pokemon is equal to 33%. The alternative hypothesis is that the true proportion of legendary Pokemon is not equal to 33%. And that's what that means in statistical notation. So we're able to understand what the notation means and then communicate it to somebody as a sentence. To say, what is P? Well, it's the true proportion of legendary Pokemon. And we have this idea to start out initially that they are 33%, unless we have evidence otherwise to believe that they're not 33%. So hopefully that helps in reading it as a sentence. We want you to be able to, we don't want it to be math, we want it to be like understanding. And so what do you notice about 33%? 33% is where to the interval. So this is where it wants you to connect the idea between a confidence interval and a test. That's basically understanding how to read statistical notation. 33% is way where. I am 90% confident the true proportion of legendary Pokemon is contained in the interval 3.4 to 7.6%. So I would definitely reject 33% because 33% is way outside my interval. So 33% is not a plausible value. The plausible values are the ones contained in the interval. Anything outside the interval can be rejected with a 10% alpha. Reason is it's 1 minus alpha is the, or excuse me, 1 minus confidence level is the relative alpha level equals the relative alpha level. How did you find the interval? The interval was made from us previously right here. I am 90% confident that the true proportion of legendary Pokemon is contained in the interval, and then the interval right there, and that is created going to the output and going to, and then really quickly, Blakely, I'm gonna remove this just in case. Oh wait, sorry, I'm gonna remove the message. One thing, just I always want to make sure we really hate doing anything with plagiarism. I just would hate for someone to be like, oh, I saw that in a video, so I wrote it down. So, but yeah, like I think I saw it, and I think that's what we're looking for. Saying, you know, I believe that this is this. That's what we're looking for right there. That's what we're looking for. Throw you some points right there. Make your interval. Make sure to go right here to histogram, confidence intervals, and then other. How you doing, Caroline? And every section in the video is marked. I'm even gonna hit the save now to make sure we save everything. But if you miss a section, this is all recorded, and I'm trying to do it in 5-minute chunks. So that way you can come back and go to a section again and see which section we're doing. And I would definitely reject 33% because it's way outside my interval. This also coincides, I'm too afraid to say things fully. You know, if you look at that test right there, low p-value, reject the null. That's the null, I reject it. It's outside the interval. Speaking just chunks of words. But how are people doing on the test? Anything within the interval is a believable value. And if it was within the interval, we would not reject it. Anything outside the interval is a value we would not believe and thus reject the value. How are we doing? How are we doing? We are done with this section, I think. We have now done 20 points right there. A large chunk. 20 points done. One sample t-test. You're welcome, Blakely. Good work. So let's start up what a one sample t-test is. A one sample t-test is used to test the what? Remember Mr. T? And good to see you there. What is a one sample t-test used for? Or one sample t interval? So the one sample t looks like the following. One sample t would be y bar plus or minus t star n minus 1 degrees of freedom s over square root of n. Also, y bar minus mu naught over s over square root of n. This is the interval. This is the test, where y bar is the sample mean, t is the critical value, or we solve here for the t, where we solve for the test statistic. And critical values are used for confidence levels, hence why it has the star on the top one for the interval. The S is the standard deviation of the sample, N is the sample size, Y bar down below is the sample mean, mu naught is the hypothesized mean, S is the sample standard deviation, and N is the sample size, and T with N minus 1 degrees of freedom is going to be the test statistic calculated by the standardized difference of the difference between the sample mean and the hypothesized mean over the standard error, which is S over square root of N. So these equations will be very important for the test, and knowing your
notation, brother.
Leo right there is going to be key. Let's go ahead and look at what we need to do, and we need to first create a histogram. So let's go ahead and make said histogram. So making the histogram right here, Stat1 project, making the histogram. Make a histogram, make sure it has a count axis, is in horizontal layout, and include a screenshot of the visualization, including the summary statistics and quantiles section. So we go over here to jump, we go to our data, and I'm going to analyze the attack power. Here we go, analyze, distribution. Double click the variable of interest. Make sure it's there in Y columns. Once it's in Y columns right here, go ahead and click OK. Now that you have this, you have the histogram. Go ahead and click the red arrow up top and click stack. Now, go ahead with your histogram and click the following. On the second red arrow, choose histogram options, count axis. And it's in horizontal layout with a count axis. I think that's everything. You can also choose some nice colors under histogram options and choose a color, whatever you want. I like to do light purple. Light purple. Different light purple. So with this, you now have your histogram. You should understand the histogram has a shape, center, and spread to it. So looking at this, it looks a tiny bit right skewed, a little bit, not too much. A little bit of outliers up here. Might be our legendary Pokemon for all we know. If you see that data is selected, go here to rows and go to clear row states. Should we try and pick a... it might, for meeting conditions, not a bad idea. Space Cat, good job right there. Space Cat's already kind of getting to condition number 3, and that does kind of look nearly normal because the histogram is unimodal symmetric. We also have a very large sample size here of 312, and that would be large enough such that even if there is a little bit of skew, the distribution of the mean would be nearly normal. So Space Cat, that will help with saying the third condition is met if your data looks kind of normal to begin with. So good job right there, Space Cat. I think that's a decent idea to maybe work ahead and meet a condition. You don't have to meet the conditions, but they're not bad to meet. They're better to meet. So with this right here, we have our data, we have it graphed, and let's look at the next portion of the project. Provide a short write-up explaining the shape and appropriate center and spread for the distribution. So shape is going to be things like your histogram, and I got to pause right here because it could be many things. We're talking just about the shape, and let's call this describing a histogram. This goes way back in time to the earlier part of the semester. Yeah, what you need to click to do the histogram, you got it. So to make a histogram, go here to Analyze, Distribution. Under Analyze, Distribution, you can double click the variable you want, like attack. Once you've got the variable right here, you're welcome, Kyle, click OK. Now that you've clicked OK, go to the top red arrow and go to Stack, and it goes in horizontal layout. Go to the second red arrow and go to Histogram Options, Count Axis, and you can add the count axis, and the second red arrow is where the options are at. You can do things like histogram color. We always go for that light purple right here. So now you have your histogram in horizontal layout. I always make it a little bit bigger here too. These are just options, not required, but make the picture look good. We like that. How's that work, Space Cat? We now have the histogram made, and we are now going to describing histogram. Timestamp this right here. Yeah, count axis. And you got it now, right? Yes or no? You have the count access now, I believe. Histogram options, count access. So make sure to do histogram options, count access. Histogram options, count access right there. Good stuff. So now we need to describe the shape, center, and spread of this histogram. With the shape, hey Samantha, good to see you there. The shape, center, spread. The shape is going to be either like unimodal, bimodal, multimodal. It's going to have right skew, that's right to the high, left to the low, whatever way the monster man's tail goes. It's going to be symmetric if it is. You can't say all these things. It might have outliers, but you have to look at it and think about it. My histogram is mostly symmetric with a little bit of right skew. There are 3, maybe 4, I'm going to highlight. There are 5 high outliers. There's 5, I'm going to go to clear row states again. There are 5 high outliers with values as extreme as 180. Wow. So you can see it there, the max. So think about what I said. My histogram is mostly symmetric, but has a tiny bit of right skew. If you're wondering about skewness, this is not required, but you can go to summary statistics, customize, and go to skewness or skewness. There it is right there. And it should be positive if I was right. And it does have a little bit of right skew because that's positive. You don't have to do that, but if you're wondering, you can measure skewness right here with positive or negative, positive being right, negative being left skew. And so we do have a mostly symmetric with a tiny bit of right skew histogram that has 5 extreme outliers with one as high as 180. It is also unimodal with the modes centered around 75. I'm just going between these 2 bins right here. Also, it's kind of median. And now it says, make sure to talk about the appropriate center and spread. So since I've said that it is mostly symmetric, I'm going to go with what for center and spread. Since I said it's mostly symmetric, I'm going to go with what for center and spread. This is a review question from a long time ago. And Cam, good to see you there. It's not required. It's just found under here, customized summary statistics. And if it looks mostly symmetric, it should be close to 0. And you click skewness and click this. Not required, not on stat to 1, but it's how to measure skewness. Positive is right skew, negative is left skew. If you're like, what way skewed is that? If it's close to 0, it's symmetric. And that's mostly symmetric. So since I'm saying it's mostly symmetric, I'm going to use what values for the center and spread. And if the graders are mean to you, let me know, because this is a little subjective. Mean and standard deviation, Caroline, exactly. Since my histogram is mostly symmetric, I am going to, the center of this histogram is the mean, which the average Pokemon has an attack power of 80.16. If it was the median, I would say the 50th percentile of attack power of Pokemon is 77. Don't just say the median is 77, but if I said it's skewed, I would have to say the median, which represents the 50th percentile of attack power of Pokemon, is 77. Notice how I'm always giving the context. Next, we would say the spread of the data is properly described by the standard deviation, which is 32, which gives a typical distance a Pokemon's attack power is from the mean. So the standard deviation is a typical distance from the mean, where the IQR is the range of the middle 50%, and the IQR would be 41.75, found by doing 100 minus 58.25. Now, I need to just write this out right now. Don't give all the values. Don't give all of these. Why are you not giving all of these? Don't give all of these. This is part of the project right here. Even though you just heard me give all of them, I'm just trying to explain how to interpret if you theoretically were interpreting them, because I don't know what your project will be. So the median represents the 50th percentile of Pokemon's attack power, which is this. The IQR represents the range of the middle 50% of a Pokemon's attack power, which goes from blank to blank, and is this. The IQR was like 41.75. The mean represents the average Pokemon's attack power of 77. The standard deviation represents a typical distance the Pokemon's attack power is from the mean, which was 32. Why are you not giving all of these? Why are you not giving all of those? Don't write exactly what I said. I think about your data and how it matters to you. Why are you not giving all these? Because the proper center and spread are based on the what of the data. Exactly, yep, goes back earlier. It depends on if it is skewed. So the center depends on skewed or normal. So the center is the mean or is the median, and then the spread is either one standard deviation for more normal data or the IQR, which is the range of the middle 50%. So 50% there. So does jump directly show IQR? It can. Guess where? In SpaceCat, really great questions. You can get the IQR in jump by going here and going to summary statistics, customize summary statistics, and then ask right up here, it's on here somewhere, for the interquartile range. So just ask it. Yeah, I can. Yeah, and if you feel the graders are mean, let me know, because it's a little subjective. And there's that 41.75 found by subtracting 100 minus 58.25. Summary statistics, customized summary statistics, and then you can get the IQR, which is the range of the 25th to the 75th percentile. Good answer, SpaceCat right there. We're gonna do the whole project in this video, so I will go over, so don't worry. And if you have to leave, it is recorded, and I'm doing each individual section right here. I've been taking lots of notes, and we're gonna make sure to save it, so you will see each individual section. If you're stuck on something, people can then resource this video. So next, create a confidence interval. Don't choose 90, 95, or 99. So my standard deviation is, so standard deviation is just a measure of spread. Unimodal symmetric is only measured by, so unimodal means this bump right there. That's how you tell unimodal, how many humps there are in it. And then symmetric would have to be usually a visual interpretation. But if that is, so SpaceCat, if that is your skewness, not the standard deviation, if that value you quoted me was your skewness, your histogram probably looks way like this. Does yours look like this, SpaceCat? If that is your value of skewness, not standard deviation though, because skewness is not standard deviation. Skewness is just a measure of which way it skews. It's a different thing we've never calculated, but you can calculate the skewness. Standard deviation is up there. That's S for standard deviation. If your skewness is 4.4, your histogram probably looks like that. Is that correct, SpaceCat? If your skewness is 0, it's going to look more like this, or it could be flat technically. But skewness of 0 means perfectly symmetric. Negative skewness value is left skew. Positive skewness value is right skew. So then, from what I'm seeing, that's mostly symmetric. It probably looks a little bit like this, SpaceCat. Does it look a little like that? Let me yes or no in the chat. Does it look a little bit, like if I had to draw your histogram, I bet you your histogram looks, Google. I bet you your histogram looks a little bit like, just a little extra tail down there on the bottom. A little. Oh, and it's bimodal? Yeah, it's probably something like that. And a little left skew. So overall, I would say you're good. I probably, unless you could send to me or something, I could look, but I'm guessing it probably looks mostly symmetric right there. And you're probably gonna use mean and standard deviation right there. So I would go with that right there. Definitely mean and standard deviation. And good stuff. Describing the histogram. And now we have to make a confidence interval. So let's go make the confidence interval. You're welcome. Confidence interval for the mean. To do that, we're going to go to our output. And you already have to have this open. You're going to go to the red arrow and go to confidence interval and then other. Confidence interval, other. And once you click other, you'll enter in another number, not 90%, not 95, not 99. I am entering in 90 because you can't. So please don't enter in 90. I'm doing it because you can't. I'll repeat that process again right here so you can see it. Click the second red arrow, go to confidence interval, and under confidence interval, click other. Then enter a value other than 90, 95, or 99. I'm entering that in because you can't. So we're going to go ahead and click OK right here, and we get the confidence interval over on the screen. Let's go ahead and take a screenshot of our confidence interval. Get a nice pretty screenshot right here. Here we go. Screenshot confidence interval. And bring it over here. Now what I'm going to do is I'm going to bring this back. Right here. This one. Yes. You'll notice this looks a lot like the confidence interval for, or yeah, it does, like the last one we did for the proportion. So think about this. This was our interpretation for proportions. And we can basically use it for means. I don't know why it has that extra space right here. There we go. I am blank percent confident that the true blank is contained in the interval blank to blank. I'm gonna give a pause right here, play a little music, which I don't get to hear today. But how would we interpret this? How would we interpret this? I am blank percent confident. Try to fix my music. The mean, you are correct. The mean of what? Remember what I analyzed? What did I analyze? What I analyzed, I'll put it over here. There it is. There's the context as I try to fix my audio real quick. I am 90% confident. How do we interpret that? I did break something. We're like, don't break it. I am what percent confident? Start highlighting right here. Give it a shot. This is on the test. How do we interpret this? Well, you got it. You got the context. So try the full thing, Space Cat, because this is on the test. There's questions like this on the test that ask you to interpret it. And so you have to know how to write this. Once again, these are things we don't get people in trouble for interpretations, because how do we do this? Because a lot of people are going to do the same thing right here. What do we have? How would this be interpreted? What would we write? Really good practice if you can do this. If you get to the test and you haven't done this a few times, you'll be very confused. You'll be like, what did he say? What do we write? And the more you just do it and practice it, and you can do it on your own, like, I am blank percent confident that the true blank is contained in the interval blank to blank. Just write you, one can be, you can say one can be 95% confident that the mean attack, but you have will, will is a little iffy of a word, so close. We'll throw you some points. Space Cat, good answer right there. So you ready for this? Watch this right here and good answers. We're gonna say, I am 90% confident that the true mean attack of Pokemon is contained in the interval 30.09 to 34.35. I am 90% confident that the mean of attack is not, you can expect it as all right, is contained. We did expect it with the slope, right? Or expected differences, right? That will is a strong word, and we don't even need the will. If you notice right here, I don't have a will. Some graders may tick off for that. They may not. If they don't, I wouldn't go back and regrade it if I saw it. But if they took it off, I might say, yeah, will is saying certain that it's in there. Because the 90% confident doesn't mean it will be in there. It's just how much percent we expect it. Like 90% of 90% confidence in the long run will contain the truth. So, great job, Caroline, right there, and good practice. I am 90% confident that the mean of Pokemon attack is contained in the interval 30.09 to 34.35. You can probably do 2 decimals. The amount of decimals you round is going to depend. This is kind of like, you know, it's 30 something, so it can be rounded to 2 decimals. So good work right there. There is the interval, and there is the interpretation of the interval. Name the 3 conditions. Let's go over here and start talking about those 3 conditions for the interval. We're rocking and rolling. I think we're about halfway done at least, and just a little over an hour in, right about an hour. So conditions for interval for the mean. Nice to see you, Rex. We're getting pretty far in the project right now. So the 3 conditions. Condition 1. There you go. Condition 1 is random. And we just did the conditions earlier for a confidence interval for the proportion, and the intervals are the same thing, or the conditions are the same thing, but there's a difference. We like to say when you get to the 3rd condition, before saying it, you pause. And I always ask people to put them pause in the chat. So I'll put pause in the chat right here. We put pause in the chat because we pause because the 3rd condition is going to be different depending on if you're doing categorical or quantitative data. I want to give a big shout out to a video I have here under review 3. If you go to review for test 3, a video I made where I start the sentence with you can see the conditions. We don't have the material. Oh my gosh, the material's posted for exam 3. Thank you, Terry. Terry right there. There it is. You can see a screenshot from the video, and you hear the
this is one proportion.
and when I go further into the video, you can see the conditions, and you can see when we do the t-test, which is over here, the 2 sample t is this one, the 1 sample t is off my reaching ability. The t-test uses the nearly normal. So we'll mention that just briefly here. And what is the nearly normal? Success failures for proportions, and expected cell count is for chi-squared along with count data. And the 2 sample t has the independent means condition, which we're not doing right here. So those are the conditions for these. If we do a regression, that has different conditions coming up here. But going back to our sheet with the conditions, that's not the sheet. Well, rewrite it. We have random, was our data randomly selected? Make sure to go into detail on that and write a sentence on whether you think your data was randomly selected. 10%, which is less than 10%, means we selected less than 10% of the population. You need to tell people what your sample size is and what your population size is, and then accurately describe whether or not your sample is less than 10% of the population. Make sure it's less than 10%. Last but not least, there is the nearly normal, because we are doing quantitative data. If it was categorical, it would have been success failure. The ways to check the nearly normal are: 1, does your histogram look unimodal and symmetric? And if it does, you're good. So mine's pretty good on that, but I could make a normal probability plot. Does it follow the line? Now, this is not a linear relationship. I'm not going to do these super slowly because you might be able to look at your histogram or use the last option to say it meets the nearly normal condition. To do a normal probability plot, I'd have to go here and click the red arrow and go to normal quantile plot. Does that mostly follow the red line? I'd say yes. I could include that. If someone wants, you can do this. And you can say, I also made a normal probability plot. And you can include this and say my normal probability plot mostly followed the red line. And thus, I think the data is nearly normal. Notice how it mostly follows it. There's not that many deviations. That is not required, but it's one way to check it. These are just ways of checking it. Next, you can also do a goodness of fit test. Is the p-value above 0.05? If so, normal enough. So we go here, and these are not required, hence why I'm doing them a little bit quicker. We go back and we go to continuous fit on a normal. There's the red arrows. I'll pause in case anyone wants to follow, but these are not required. We fit the normal, and it fits a normal on top of our data right there. You can see the green line, the green normal, Gaussian curve. And then we go to the red arrow here and go to, where is it? Goodness of fit. There we go. Goodness of fit. And the p-values are low, probably due to statistical power. Since the p-values are low, the goodness of fit test actually comes back that it's not normal. Now, the reason I went through these a little bit quickly is because we had a condition previously called large enough n, large enough sample size. If your distribution is heavily skewed, a sample size of more than 100 is large enough that the distribution of the mean will be nearly normal. So we previously did the large enough n condition, but now part of the nearly normal is the large enough n. Sorry, that's confusing. Stats is that way sometimes. But the nearly normal can just be done by looking at a histogram of our data. And if your histogram looks pretty good, you probably want to go into detail. Well, I described my distribution as mostly symmetric and unimodal, which is how the normal looks. And with that, I used the mean standard deviation, so I told you I think it's pretty normal. So is it nearly normal? Well, yeah, I called it normal to begin with. But if it were to have issues, you probably need to go down further and probably use the large enough n. So my suggestion is this, especially if you use the mean and standard deviation, talk about how normal it is and explain that to people. Well, here's why I said it's normal. If your distribution was skewed, you talk about how the large enough n allows for the distribution of the mean to be nearly normal via the central limit theorem. And we're not saying your distribution is normal. We are saying that the distribution of the mean is normal. The basics of the null, oh yeah, we can swing back to that. 10% is that we're using under 10% of the population. That is correct. Your sample size is less than 10% of the population. And when we say that a distribution is nearly normal, we're not talking about these single observations up here. We're talking about the distribution of the mean. You see that a sample size of 25 is not large enough that the distribution of the mean is nearly normal. And we have every section marked in this video right now. So if you look right here, and this will be saved, if you look right here for the nulls and alternatives, that would probably be under the one proportion test. That's when we're talking about the nulls and alternatives for the first test. We might be doing more of that in just a second. So really good questions. Thank you, Peyton, right there. So now, next section right here. We have the conditions, interpret the interval. Guess what? We just got another 20 points. Make sure you've interpreted your conditions, you've interpreted your interval. I am blank % confident that the true blank contained in the interval blank to blank. Who's been following along and has pretty much everything written out for the first two sections right here? Now we get to 2 more sections, and they're not that bad. We'll be pretty quick. Has anyone been following along and is pretty good into the project? I hope right here. And so this is, yes. Okay, side-by-side box plots. Side-by-side box plots are used when you have a categorical X and a quantitative Y. So it would look the following way. They are box plots side by side. Now my guess, and we've done this before because I've read through the project and everything, is legendary is going to be down here and attack is going to be over here. Attack is a quantitative Y and legendary is a categorical X. So let's go ahead and analyze the differences in attack powers between legendary and non-legendary Pokemon. Well, so all these are different pages right here, and I was actually meeting with a company this morning that would allow me to do those things super easily. I'm actually pretty much excited about it. I'll even tell Adam, the director of technology and enhanced education, that so basically I could make this board for you guys and put different documents in it, and then you could actually access all the documents. I do think there's something to people writing down notes with me though. So that's the thing. So Grayson, really good question. And then taking notes and working along, I think is great. But then I'm also like, maybe it would work. There's one semester where I posted all my notes and grades were lower. I remember all these things. Teaching is weird. It's so weird. It's like, how do you teach right? And you just don't know. Like, you're like, I'll post all my notes. And then I think people weren't taking notes. The grades were the worst ever that semester. So I don't know. Teaching's weird. That's my thoughts on teaching. Like, I'll do this, it'll help, and then it hurts. So let's go and make these side-by-side box plot right here. Provide a short write-up. So use the quantitative variable and categorical you had from the previous 2 sections. So you've already decided your variables. Provide a short write-up of the nature of the relationship, first describing physical characteristics of the box plots, explaining what is similar or different about, helps you understand the 2 groups. Do the levels of the categorical variable have any effect on the quantitative? Second, support your reasoning by using numerical information of the center and spreads. You go over the interpretation of the confidence interval of the T. Yep. So that was where we said I am. Oh yeah, Space Cat, you were doing it. Here, I'll pin Caroline's message. Here's what Caroline wrote, and this is what we were doing. I did it a tiny bit out of order. It is under the interpreting or confidence interval for the mean right before conditions. I interpreted it right away. So I pinned Caroline's message up there, and then we were doing that right there. That was the interpretation of the I am blank % confident. Good questions right there. Thank you for asking. I want to make sure we don't miss a section. I did, yeah. No, I did miss the conditions, so every once in a while I miss something. So let's go ahead and make this, and here we go. Please remind me if I missed something, because I don't want people to do poorly on the project from an error from me. Analyze, fit y by x. Analyze, fit y by x. You know what? Let's go here to graph. Nah, graph builder has the problem, so we'll do analyze, fit y by x, because you don't have to worry about dark mode if you do it this way. Analyze, fit y by x. Under analyze, fit y by x, put your x variable here, which is your categorical. So the x variable will be the categorical variable that was 2 levels that we chose first for the proportions. Next, we have the quantitative y, which was attack power, right there. So you should have categorical 2 level, quantitative y. Now we're going to go ahead and click OK. Now you can see there's a lot less legendary Pokemon. We're going to go next and click the red arrow and click on quantiles. There's Boxplots. There we go. A little hard to see the outliers right there. The way this one displays it, the outliers are sort of a little bit different, but because the outliers kind of go through the box plot. But these are two box plots right here of the attack power of legendary Pokemon and non-legendary Pokemon. And what do you immediately see? What do you immediately see? And there's so many sentences that can be written in so many different orders. And I think that's what people don't realize is like, there's no one way to write your sentences. And then if people go beat for beat, moment for moment, interpreting the same way, well then, kind of weird. And weird in a bad way. So, and I promise I'm not trying to, I've been dealing, all these things are the same things would happen with everyone we try to talk to us about this. So this is a thing I've dealt with, and I don't want to deal with it for this project either. It's just, if you see how your friend wrote it and they mentioned this, then they mentioned this, then they mentioned this, don't follow that order. Don't look at their project till you have yours complete and be like, if you get an idea from them and then you come home and this is the problem, is I don't want people to think that, don't copy anybody. There's a difference between, hey, I like how you talked about the IQRs and I didn't do that and I've written my full report and maybe I should mention the IQRs, and then you go home and you look at your data and you're like, my IQRs here are mostly similar. And look at this. So you shouldn't be looking at their report. You should have your report written before considering any updates from what a friend wrote or anything. And then never ever have your report open while writing someone else's report open while writing a report. And it's what you want is you want them giving you suggestions and being like, oh, you didn't notice that the IQRs are virtually identical? That's what I wrote in mine. I talked about, and your IQRs look like this. And then you don't want to write the exact same sentence as them, and you don't want to put it in the same structure as them. So you want to write your report. You don't want someone telling you what to write. You want them helping you see things. So if they point this out, like you didn't notice the IQRs, as long as black is, what is the long black line in the plot? Oh, good question, as I just rant here. The long black line is what is called the grand median. It's not a silly question at all. The grand median is the median of all the data. That is called the grand median, and it's weighted towards the non-legendary Pokemon. That is called the grand median. The grand median. Surprised I know that. Just learn random things, but that's called the grand median. So weird terminology. It just means for all the data, the median is this, and we don't even quote it. It's a little bit. It's in between the two because there's two groups and they have different medians. The IQRs are virtually identical for these groups. The range of the middle 3% of each group is basically 40. Oh, there's the IQRs. Where they really differ, where do my Pokemon really differ? The Pokemon really differ what? In their whats. There's two values I'd say they really differ on. Where do the Pokemon really differ? And these are the things you'd want to write up, like the differences. The Pokemon really differ where? Where do they really differ? And they want to give the numeric backing. Where do they really differ? I see two spots. They really differ on the 50th percentile, the median. The median non-legendary Pokemon had an attack power of 75, where the median legendary Pokemon had attack power of 100. The minimum, which is the lowest of the attack power, the lowest attack power for a legendary Pokemon was 50, which is below the median for a non-legendary, but nowhere close to a 5 attack power, which is probably a Shuckle or something. But the 5 attack power is well below, which is the minimum for non-legendaries. This might also be because there's way less legendary Pokemon, but still, there's big differences. Well, the differences in the min might be because of way less, but there are big differences here. Make sure to quote those differences, and we see that legendary Pokemon have a higher median, have a higher max. The maxes aren't that different, with a difference of only 10, ranging from the non-legendary max being 170 and the legendary max being 180. Does this make sense what we want you to write here, Space Cat? It'll be for you and your data. So I don't know what you'll write, but you want to talk about how similar or different they are in your write-up and include the 5-number summary as seen below in this output. So there is the 5-number summary. It does have extra things in here. The 5-number summary is technically only those values there, the min, the Q1, the Q3, and the max. So hopefully that gives people ideas of kind of, you don't have to blank those out, but the 5-number summary is included right there, and the IQR is the distance between the Q1 and the Q3, the interquartile range. So guess what? We are on the last major section of the report. 15 points. 15 points. I said that section would go quick. I knew it. Tell me how you're doing in the chat right here. Last major section. What is regression? What is regression? Regression is the relationship between two quantitative variables. So you have to do a regression. QQ, two quantitative variables. Straight enough. There should be no outliers. Last but not least, so no outliers, you don't want to see things over here. And you don't want plot thickening or thinning. It just should stay about equal strength throughout. The model's predictive power should not change. It should stay the same. That'd be bad right there. Feeling, oh, you're welcome, Space Cat. That's really nice of you. Yeah, and thank you for being here. You know, Space Cat, I usually don't make you a mod. You seem to be doing the project. Boom, Space Cat, new mod. I'm getting 1,000 points. It's a way better having someone here to chat to do the project with. So Space Cat earned a mod right there. We like that. Your name will be in blue now, and you get special mod powers. So select another quantitative variable, because we need two quantitative variables that you may suspect have a linear relationship. I think attack is probably related to defense. And I guess they might be positively related, like stronger Pokemon, but they might also be negatively related. So you suspect has a linear relationship with the first. Create a scatter plot. Identify the direction, form, unusual features. Why no strength? Strength is how strong it is. Obviously. Clearly note any outliers that may exist in the scatter plot. You will leave these data points in the analysis, but you must clearly identify any unusual features or outliers. Let's go back and make the scatter plot. Mark this section. We're going to go back to our data, and we have what is regression. We're now going to do the section on making the scatter plot. Okay, with making the scatter plot, we're going to go here to Analyze and then Fit Y by X. Analyze, Fit Y by X. With Analyze, Fit Y by X, you're going to select the first variable you had. And it doesn't say which one has to go where, does it? It just says select two, right? Select another quantitative variable with a relationship with the first. So maybe something's related to attack. We'll put attack up there, up the top. So attack is the Y variable of interest. And I think defense is related to attack. Like the best attack is a good defense. Best defense is good attack. Sure, why not? And they might be positively related, but it wouldn't shock me if they're negatively. But probably stronger Pokemon have higher attack and defense. Let's check out by clicking OK. And ooh. There is a positive linear relationship here, but I definitely have some issues. It's a decent scatter plot, but I'm going to use the lasso tool right here and circle these. So the lasso tool, I want to grab that one. The lasso tool is this. It's found up at the top on a Mac, I believe. You don't have to do this on a PC. You might also have to click to make this bar appear. But once I've selected these, I'm going to go to rows and then color, and I'm going to put them in red. And then I'm going to select these right here and lasso them. And we're going to go to rows and then color and then red. And then I'm going to go back to the pointer tool and click a blank spot. This is not required. I'm just trying to make it very clear where what's are in the plot. Who knows, for some points. I'm trying to, and you can see them, but I could say, I've tried to make it more clear to you where the what's are by highlighting them here. These are the ones I think that are outliers. Oh, I said it. They're outliers, or they might be the plot thickening, but either which way, I think there's a bit of an issue. Where is the person in person? It's going to be up here at the Milton area, Milton area, SMC floor 2, right next to Haslam. My office is in a slightly different location. I recorded a video at the start of the semester. One moment, I'm going to post the video. Maybe I'll send this out today too. Okay, so this is not quite where my office is at now, but you'll find our floor with this. So there is a video right there. 5 years ago, but I need to update it. 5 years ago. Crazy. So I need to update that. And we have the outliers right there. And thank you, Jessica. We have the outliers highlighted. It looks straight enough. I did use 2 quantitative variables, but there seems to be plot thickening or outliers highlighted by the points that fan out. You're welcome, Jessica. So this seems to be somewhat of an issue. And let's go see what they want with this. There's our regression. And you must clearly identify any unusual features or outliers. I highlighted them, and I also told you I think it's plot thickening, and I think they could be outliers. Kind of a dual issue that there's a bit many of them for it to be just outliers. It could be plot thickening, but there's something going on where the plot doesn't remain equal, or we have outlier points far away from the model. Perform a regression analysis and evaluate the 4th condition of plot thickening right here. That's the 4th condition. Plot doesn't thicken, and we need to make a residual plot. So here we are with our regression analysis, and we are going to go to the red arrow and go to fit line to fit the regression line. Once we go to fit line, boom, here's the regression analysis. To do the 4th condition of plot thickening, we click this red arrow right here, and under this red arrow, we go to plot residuals. And with the residuals now plotted, I do see a bit of plot. Actually, it's non-linearity. So maybe the plot gets a little thinner towards the end. Mine's a weird one. I'll tell you that. Mine's a weird one. I actually see, surprisingly, you can do this with, right here, watch this. With this, draw around it. This is what we had to do when I was an undergrad. Draw around the majority of the points. You see how the plot gets thicker over here? It's not what you want. Now, don't look too much at it. I don't think many statisticians would say this is passable, but you could technically include this right here with the drawing over it. They should like that, because you could say, I see that the plot is thicker at the start and thinner at the other side of it. That looks to be an issue. Fit line is not an option under my scatter plot. Double check. And here, Caroline, good questions. Make sure you've done analyze and then fit y by x. With analyze, fit y by x, make sure it's 2 quantitative variables. You see 2 quantitative variables right here, Caroline? 2 quantitative variables. With the 2 quantitative variables, click OK. Now it should be the red arrow here and then fit line, and it should have the dots on it. If it doesn't have the dots, it's not a scatter plot. Does it have like dots all scattered, or if it has something else, it's not a scatter plot? Like if it has names down there, that means a categorical variable was used. Because that, it might say like t-test or something like that, but it should have the dots everywhere, and that means it's a scatter plot. And you should see a quantitative axis here and a quantitative axis here. Does that make sense, Caroline? If you see a quantitative axis and a quantitative axis where it's like numbers and numbers, then you've done 2 quantitative variables, the QQ for regression. If you don't, then you won't get the option to fit a line, because regression is for 2 quantitative variables. So that might fix the issues, I hope. And once you fit the line, make sure you go here afterwards and go to plot residuals. And then you can take a screenshot of this first plot right here and see if the plot is thickening, which mine does at the other side. Great job. So it does look to have some plot thickening, not quite how I expected. You want to know a secret? The lack of fit's going to have a low p-value. Yep, low p-value on lack of fit. I'm not going to talk about that. That's a lack of fit, for goodness of fit, of the linear model. I'm going to stop talking. But that's what I suspected when I saw this. I saw that non-linearity at the end. So non-linear, the line is kind of going through it weirdly. So weird regression. You get weird regression sometimes. So with this, let's go back to the sheet. And we talked about the plot doesn't thicken issue. The 4 conditions. Let's go over the 4 conditions again. Put it in the video right here. We've made the scatter plot. We've made our graphics. I do want to make it clear that you need both your output for this. If people are wanting the output before I go to the next section, you need your residual plot. You could draw on it probably like I did. Then you also need to take a screenshot of the regression itself with the summary statistics. So the screenshots you're going to need for this are going to be as follows. Oh, we don't need the ANOVA or lack of fit. Okay. So there we go. There is the screenshots we need. We'll be using these shortly here. There's our screenshots. Good stuff right there. And so now the 4 conditions for regression. What are the 4 conditions? Does anyone know in the chat? We've said it a lot before. It's not random and 10% anymore. We're going back to test 2. What are the 4 conditions for regression? Problem is, a lot of people might go to like ChatGPT or something and get answers, and then the answers are like, we don't know. And then they might be worded very differently. QQ straighten up, no outliers, plot doesn't thicken. That makes me so happy, 5,000 points. So the conditions are QQ straight enough, no outliers, plot doesn't thicken. So 2 quantitative variables, might want to call it that for the graders, 2 quantitative variables. Write these as sentences. 2 quantitative variables, QQ straight enough, the line goes straight through the data, no outliers, plot doesn't thicken. QQ straight enough, no outliers, plot doesn't thicken. 2 quantitative variables means both your x and y were quantitative. Explain if that is met. Straight enough means the data has a linear relationship decently that the line works well for. An example is data that kind of, and you're looking at the dots. Do the dots mainly follow a line? I thought they did. And apparently it's iffy. I would say it's iffy. After seeing that line not really go through the middle of the data, the line has problems at the bottom where it's not going through the center of the data. And I'm going to highlight that for you. So you want the line to be cutting through the middle of the data, and that looks to be the middle of the data. But is it a polynomial model? Hit the spline. Don't do what I'm doing here. I just have to know answers to this. A spline is an overfit model, and it goes nonlinear. Oh, it's that downward pull at the end. So it's linear till the end. That's what it is. That's not okay. That's the answer. This is what's going on with the data, and fitting a spline can do that. That's under fit and spline, and they just click one and adjust it accordingly. But the data has nonlinearity at the end. That helped me understand it better. The model is mostly linear throughout the start of it, and then has nonlinearity. And I hope maybe that makes people see it better. I just couldn't figure that out in my head, that these are not, they're not so much outliers, it's a nonlinear trend for high defense Pokemon. Apparently when you reach a certain high level of defense, they just don't give you an attack, you'd just be an OP Pokemon. So that is what's going on with the data. It's mostly linear, and then there's nonlinearity at the end, as we saw by overfitting to it. So there's a nonlinearity at the end, where they just destroy your Pokemon on purpose. So it's my data is mostly linear, but there's a bit of nonlinear at the end. I have concerns about that. My line cuts through the middle, but the data is much thicker than the line. How would you interpret this? It might be a plot thickening. You might have to send it to me, Caroline, or Swing Office Hours. I'd probably have to see it. Maybe DM me in Discord. I probably have to see it to tell you how I interpret it. No outliers. You might say also those are a bit of outliers at the end, the Pokemon that have way lower attack than we would expect. So I think I have issues there. Plot thickening, we also kind of saw in the residual plot where there is a issue at the end of the model where it's not as thick. So that is an issue. So mine passes QQ. Mine has issues with straight enough because the model seems to bend at the end. Those might be due to the outliers, so it might also have issues with outliers. It also has issues with plot thickening, probably because the model is not nearly as thick at the end. It should have equal thickness. The dots should be like this in a residual plot, making it the same, about the same thickness throughout. So I have concerns about this regression. Maybe this is not a good idea to do. That's what I would say as a statistician. So, well, as a business analyst, my dad always like, you're not a statistician. Like, why try? Right up the, and we're here. We're at the end. This is it. All we have is some executive summary and future research after this. So now let's do it. Stat201 project. Slope, intercept, and R squared. R squared and significance. Forget that, Brian. And significance of model. Okay. So, or let's do significance as its own thing. Okay. These are the interpretations we've had previously. And when we do the interpretations, so I have a video on this, and I'm going to display it on the screen right here. Review for test 2. It's easier than me typing it out. There's my channel. Playlist. View. review test. Test 2, chapter 8. Here we go. And so when we interpret these, I have blank interpretations I've been using for years, literally 8 years now. Did it over Thanksgiving break years ago. Don't believe me, you click on this and it says, oh wait, I didn't? Oh, I did the TI tutorials then. Okay, I promise you I did the TI tutorials. TI tutorials was over Thanksgiving break. And there it is. Here is the interpretation of the intercept. And if you see right here, this is Saturday text. We are predicting. So when x is equal to 0, we expect y to equal b0. The value of b0 is this value. The value of y is this value. The value of x is going to be Wednesday text. So when Wednesday text is equal to 0, we expect Saturday text to equal 19.03 on average. There is the interpretation of the intercept for this data. Now, let's do my data. On my data, I have an intercept of 46.52. And if it helps, mark these. This is the value of y. This is the value of x. This is the value... Oh my gosh, what is wrong with me? This is the value of b0. This is the value of b1. And this is the value of x. So when defense is equal to 0, we expect attack to equal 46.52 on average. When defense is equal to 0, we expect attack to equal 46.52 on average. And notice how this follows the format of the video right here. When x is equal to 0, we expect y to equal b0 on average. Next, we get to the slope. For each 1 unit increase in x, we expect y to increase or decrease by b1 on average. And if it's increase, it's positive slope, decrease, negative. So right here, let's plug in the numbers. For each 1 unit increase in Wednesday text, we expect Saturday text to increase by 1.1 on average, because that's B1 right there. So for my data, for each 1 unit increase in defense, we expect a Pokemon's attack to increase by 0.46 on average. For each 1 unit increase in defense, we expect a Pokemon's attack to increase by 0.46 on average. That's the interpretation of the slope. These will be kind of more formulaic. Everyone kind of writes sort of similar stuff with different words. The R squared is blank percent of the variation. Oh no, Space Cat, you're almost done. Blank percent of the variation in y is explained by the variation in x. So if the R squared right here, we have to see it in the video, is 74%. You see 74 right there. And you multiply by 100. So it's going to be 74% of the variation in Saturday text is explained by the variation in Wednesday text. So for my data, we go right here, 19.5%, I'm rounding it. 19.5% of the variation in attack, there's y, is explained by the variation in defense. 19.5% of the variation in attack is explained by the variation in defense. That should do it. There's the 3 interpretations. When x is equal to 0, y is expected to equal b0 on average. For each 1 unit increase in x, we expect y to increase or decrease by b1 on average. Blank percent of the variation y is explained by the variation in x. I got it. Okay, this is the last major thing, and it's statistical significance. And we do need one more bit of output. So for statistical significance, let me mark it in the video. So if someone x'd out of their output, I'm very sorry. You're going to have to go through and do analyze fit y by x. Stat 201 project statistical significance. So when you do the statistical significance of the slope, you need to grab it from not this output. Don't use that. You need to grab it from parameter estimates. So if you want to do the screenshot, if you haven't done it yet, this would be a better screenshot right here, and you need to have that parameter estimate portion so you can get this, also get the scatter plot. But this bottom portion right here also needs the parameter estimates. So frankly, I could just add this. My gosh. Let's crop it. Right here. Oh, we're going to crop the rest of that too. Yep. And there's the parameter estimates. So if an intercept is equal to 0, the model can look like this. If the slope is equal to 0, oh, excuse me, if an intercept is equal to 0, the model can look like this. If the slope is equal to 0, the model looks like this. When the slope is equal to 0, the model is flat, meaning there is no relationship between x and y, mathematically speaking. So what we want is we want a significant slope. This has a significant slope. The intercept doesn't matter. So the significance of the slope is the significance of the model. Since the slope is statistically significant, i.e. p-value below 0.05, the model is statistically significant. Statistical significance is when a p-value is below 0.05, and 0.05 is the assumed alpha unless otherwise stated, and once again I get a p-value of this. Now I would make sure someone knows this. My p-value of my slope is this, which means the slope is statistically significant because it is below 0.05. Quote the values, make it clear that we're talking about the p-value of the slope. So that is how we tell statistical significance of a model, meaning that the relationship between attack and defense is not likely by random chance. Make sure to quote this value, not this one. I know it looks the same, but it's technically not. It's just less than 0.0001. This one is actually technically smaller. You can see it from the t right there. Larger t, smaller p-value. But now that's got the full project in the video in just under 2 hours. Let's talk about the executive summary. Maybe try to be careful on this and try to tell you what I've learned. Okay, so when you write your executive summary, there are 3 parts. Who are we and what are we doing? What did we find with numeric backing? What decisions, action items are there? So I have to think through this and write about 5 to 8 sentences, preferably 8. Don't go too small. This is the full report. So whatever you do, just sit back and listen to my executive summary of what I learned. You ready? So don't write down word for word what I'm saying. This is what I would write, hence why I'm not writing it here because I don't want anyone to copy it. I usually put things up if it's kind of more okay to write down, like interpretation of slope, interpretation of intercept. This is meant for you to be like, let's hear Brian's full report. I am working for Pokemon International, and our goal is to understand legendary Pokemon and their attack and defense. We analyzed these variables in the following report. One of our key findings is that legendary Pokemon are only about 5% of the Pokemon that exist. We did a test to confirm whether or not it's 33% and rejected that because it was way outside the interval. Additionally, we looked into the attack power of Pokemon and found that the average attack of a Pokemon was about 70, but we're 90% confident that the true attack is contained in the interval blank to blank. We then went on to analyze the relationship that attack has with being a legendary Pokemon, and there is a big impact there. Legendary Pokemon have a way higher attack on average, or a higher median attack by 30 points. Look at your report for the data. Also, the lowest legendary Pokemon had an attack power of 50 compared to the lowest non-legendary of 5. Clearly, legendary Pokemon are more powerful. Finally, we looked at the relationship between attack and defense and found out there's a slightly moderate attack-defense relationship that actually drops off at the high end so that the Pokemon with high defense are not overpowered. The non-linearity was quite clear as we analyzed the data more. Our key action items from this are going to be to introduce a new legendary Pokemon that breaks the trend. We want to give you that OP Pokemon you've been looking for. So we're going to put one that brings back the linear trend to that model. Additionally, we're going to introduce a few other Pokemon that are non-legendary that are among that Pokemon. So you're going to see more non-legendary Pokemon with some high stats that you can get excited about, and a new OP legendary, that stands for overpowered, legendary Pokemon that is going to destroy the world of Pokemon. Maybe that's not the best idea, but don't write maybe not the best idea. But notice, as you heard through, I went to action items on what we're going to do, and it was based on the data on legendary Pokemon, attack, power, defense. You kind of heard all of that right there in my decision making about what we're doing. And this is specific to my report. Now notice I pretty much told you the whole report. The last hour and a half, 2 hours has just been summarized for you. Frankly, if you watch this portion of the video, you should have an idea of what I just did and everything with numeric backing as best I could remember. Does that make sense, Space Cat, what an executive summary is? It's the full report. And then what are we doing? Which wasn't included in the earlier parts. Like the numeric backing is the report. This is the report, and you should have a lot of it. You should have a good chunk of it. And then someone could just read the executive summary. I always say you can take the executive summary off the report and you basically know the full report. It's meant to be a summary, and then the report is like the extended version with graphics to back everything. So where do we go from here? Now we do future research. And the executive summary is yours. I don't know what you'll write. You just have to think, well, who am I? What am I doing? What did I find out? And what am I going to do? It's up to you, and just be imaginative. Whatever you want to do. Last portion right here. And thank you, Space Cat. Space Cat, 5,000 points. You might not be in our class, but you're racking up some points. Right? I don't know. Maybe you are. I just don't see Space Cat. I want to see Space Cat. Appreciate you being here. Caroline, thank you for being here. Getting those 5,000 points too. Throwing out those big crazy points. So, Stat 201, project, future research. Full project in this stream right here, future research. When you do the future research, it is new ideas. New ideas. Don't go through the report again. You can make reference to or talk about things. Oh yeah, you're in, that's either which way. You might be in, I don't know which online section you're in, any section, you are welcome here. That's why I made you a mod. I was like, oh, yeah. Usually, because in the open streams, anyone can join, but you are welcome here to join in any time, ask questions. I'm stuck on this. Join the Discord, whatever works for you. So glad to have you here. Thank you, Layla. Glad to have you here. So appreciate it. Definitely. When no one's here and answering questions, then I'm like, I fall asleep. So new ideas that don't go through the report again. You can reference, it should be connected to the report. So here's what you shouldn't do. I think we should start making chicken sandwiches. Students like those. Your report was on Pokemon. What are you talking about? It's not connected to anything you just wrote about. So yes, you can't just come up with new ideas that are just nothing to do with it. But my new ideas, so once again, sit back and listen to my future research as I write it out for you, but not write it here. My future research is, you know what? I think something is going on with the generations of Pokemon, that over time, people have changed their view of what is a legendary Pokemon and the stats it should have. So we really should be analyzing how legendary Pokemons have changed over time, and going all the way back to Zapdos, Articuno, and Moltres, all the way up to, I don't know, Regigigas. What do we got now? Regice. Those are that's like 10 years ago. Going up to the newest legendary Pokemon, which I don't even know what they're called. We need to figure out the differences in stats and do a time series analysis, and then look at how people received those Pokemon. Maybe get some input from our users of Pokemon, and to say, you know, which Pokemon do you like and why? Because maybe people don't want an OP Pokemon like I'm suggesting. Maybe my action items should be looked into further before we do them. Now, I'm not saying, don't write that. I don't want everyone saying maybe my action items should be looked into further. This is just me thinking through it. Does that make sense? I'm just thinking through this right now. I'm just brainstorming. So your ideas should be your own. You don't write down what I'm saying. Don't say maybe we should be rethinking the action item. That's just what came to me as I was talking through this. These are just my ideas related to Pokemon, and don't write about Pokemon. Does that make sense for what future research is? Like, I could redo the future research again right here and say, currently right now, we have been researching Pokemon, but our competitor Digimon might have some additional info. Digimon, those digital monsters, are basically Pokemon. So we should collect info on the success of Digimon and look to how our competitor has used their stats to be successful. And then let's just model Pokemon after Digimon. Hey, Pal World, you know what I'm talking about. Let's just model our Pokemon after Digimon and only choose the most successful Digimon. That way people who like Digimon can have their Digimon in the Pokemon world. So that's another action item right there. I just started thinking, let me go a completely different, not action item, sorry, excuse me, future research, because we're going to first investigate it. We don't have the data to do this yet. I want to point out why it's future research. I'm saying let's investigate Digimon. We don't have that data right now, so that's future research. It's not an action item. I shouldn't say let's model them yet, but to make decisions about whether we should do this, let's get the research, let's get the data on this, and that's a future thing to do. Are people understanding the idea of future research where it's like you don't know what to do right now? Future research is what could we do in the future? Like what could we investigate? What could we do? What do we not know right now that we would like to know better? And this goes at the end of the report. That's not everything. Look at that. That's a lot. Woo! That is. Let's do a little marking this. That is the full project. So we're finishing up. And regression. Saves right. I'll mark it as the sections. Regression, side-by-side box plot. Should be very clearly marked for everyone. One sample T. This is the best marking of a video I've ever tried to do. I was a little bit late today. Go extra. Okay, there it is. Save this and see how it looks. Oh no, it doesn't like that. Oh no. It doesn't like this. Let me remove the stars. Hopefully I'm not. Let me remove the stars. Hear me talk, double talk. No. It doesn't like that. I thought I could put stars and it would bold it. I thought it'd be all cool. Try it again. And the answer is no. Really? You can't do that? You have to put all the timestamps in order. You're welcome, Caroline. Thank you so much. That's no fair. Why won't it let you do that? Maybe if let me try something here. Try this. Well, that's a bummer. I can't. Well. Putting breaks between them, even though I can't write anything. Now will it do it? It's still not showing. It's not going to do it anyways. Best laid plans. Not update? YouTube's look at all that. Oh, now it's not even updating on me. Well, YouTube might be mad at me or something. Well, I'll save this. I'll check back to see if it's working. That's got it. Bye for now, everyone. Bye. We've almost got these new intros ready. We're almost there.
This has been going for like 20 hours. This ends now.